Guys, welcome back to Maths on African Motives. Still working on mathematics and 3. We are going to be working on our trigonometry continuation part, that is this time working with the sketching of graphs. If we are given typical questions like this, you need to understand how to sketch your graphs from the graph of cos, the graph of sine, everything that is required in our syllabus. So before we check these questions, let us quickly check exactly what we need to understand in this part of sketching of graphs. So we have got the sketching of graphs, whereby we are dealing with the trigonometry in this case. And what is important in our syllabus, you need basically to know these two graphs. The graph of y is equal to the sine of x, and also the graph of y is equal to the cosine of x. So these are the two graphs that we are going to talk about. How are they going to affect us in the answering of our questions? All right, these trigonometric graphs that we see, they can be taken from a certain point up to a certain point. What am I trying to say? We can have these graphs drawn from negative values up to the positive values, depending with the interval of the graph that you are given. Which interval are you given? That is where you can know where to start and where to end, depending with the interval that you be given. That is the values of x represented there. But having these values, what we need to know is that these two graphs, they work in a similar way. What do I mean? They work in a similar way in such a manner that if we are to refer to the period of the same graphs, it is the same for a complete cycle. Also, the sketching of these graphs, the separation of angles by 90 degrees is the same for this graph. It is best for us to separate our angles by 90 degrees. If you are just given y is equal to cos x, we shall talk about the effect of a number that can affect x, or a number that can affect here, which is on cos or even on sine. All right, so like I said, these graphs, they are common. Let us see how common they are. The first thing that you're going to need is to know how to separate these angles. That is the step that you're going to take. So like I said, it is best to use 90 degree angle when you are given a direct sine like this. All right, so we are going to need a table. In this case, a table of values for the values of x corresponding to the values of y. All right, so we're just gonna have a table from 0 up to 360, like I said, depending with where you are taking. Let us take our values of x being greater or equal to 0, less or equal to 360. That means our x is an element of values from 0 to 360 degrees. That is what it means there. All right, so having our table here, we shall have the values of x. All right, so let us just say we've got something like this. We shall have the values of x corresponding to the values of y. So if we are to start like separating by 0 degrees, by 90 degrees, taking from 0 up to 360, it means the first point here is going to be at 0 degrees. We add 90 degrees, so 0 plus 90, it is going to be 90 degrees. We add 90 degrees, that is going to be 80. We add 90 degrees, this is going to be 270. We add 90 degrees, this is going to be 360 degrees. So we have separated each and every point by what? By 90, 90, 90, each and every point. So what you're simply going to do is that on your calculator, you can have these values taken, making sure that your calculator is in degrees in this case. All right, this is what I'm trying to say from our calculator here. Make sure that this calculator is in degrees. All right, so we can have our values like this, sine of 0 in this case, all right, which is going to give us a 0. So this is the corresponding value, which is a 0 here. The same with the 90 degrees, the sine of 90 degrees, which is going to be a 1. We move on to 180, and so on. The sine of 180 degrees, which is going to give us a 0, and so on and so on. So this is how we can take these values. The same if we move on to 270, we are going to obtain -1. This one, it's a 0. So take note what we are having on our table. These are angles. The values of x, they are representing the angles here on top. These are angles. These are direct values that we are having of y. These are direct values. So in this case, I'm going to have just a sketch, then we shall draw later on when we are dealing with our actual questions. So having our sketch, we can just say we are going to have something like this, taking our values from 0 to y. So this is our horizontal axis. All right, this is your vertical axis. So if we take note here, our points in the horizontal axis, whereby we are referring to x in this case, these are the angles 0, 90. So from this side going this way or going this way, we are representing angles. That is the values of x. All right, so we're going to start with the 0 degrees separated with same unit. Maybe you're talking about 1 centimeter or 2 centimeters, but we shall separate them equally, 90, 90, 90, 90, equally. All right, so we shall see that one later on. So that is 90 degrees. The next angle that we have here being 180. So we have got 180 degrees, 270, 360 degrees. All right, so these are the angles that you're going to use for the x from 0 to 360. Then the values of y, as we can see here, they are ranging from 0, 1. So we can see that the minimum value is -1. The maximum value is a +1. So these are the most important values. So we shall have -1. At this point, we are at 0 both for x and for y. All right, then we've got +1. Let's say this is where we have our +1 on our graph. So you are going to mark points just like the same way you draw any other graph, or it's a quadratic graph. You have to mark the points to say this point, they correspond with 0 versus a 0. So you're going to mark a point 0 for x and 0 for y. That's 0 versus 0. The next one, x, it's 90, y list y, it's 1. X, it's 90, y list y is 1. So these two, they meet at a point. If you come from this side and you come from this side, they meet at a certain point. That is where you are going to mark your point, where these two meet. Let's say they meet here, you mark your point. We've got the other point, 180 versus 0. X, it's 180, y, it's 0. So this point lies on the x-axis. 270 degrees here versus -1. So it's 270 on x, y being -1. Where do these two meet? They meet at this point. That is where you are going to mark your point. All right, so we are going to mark our point here. All right, 270 versus what? -1. Mark our point here. We do the same thing, 360 versus 0. X is 360. Y list y is a 0. So this point is found here. You mark a point again. So these are the points that you're going to mark on your graph corresponding to each other. From one value to another, we are going to join. So right, so from this point up to this point, you join. So this must be a smooth curve. All right, from this point to this point, from this point to this point, and also from this point up to this point, like this. So this is the graph of y is equal to sine x. All right, so here we have got the graph of y is equal to the sine of x. If we analyze our graph here, we are going to see that the maximum value of our graph at this point is corresponding to 1. The minimum value is corresponding to -1. Whereby this graph, if we go up to the maximum value, this is where we have a turning point. So this is actually a turning point. which is found at x is equal to 90, while y is 1, like from our corresponding values, 90 versus 1. So this one is a turning point where x is an angle of 90 degrees. Y is just a value, a normal, a direct value, a real number, not an angle, not an angle. Please be careful of that one. So x is your angle, y is a normal value. All right, if we check again after this, the graph goes to the x-axis at 180, down here to the minimum turning point, then it goes up to 360. So here we've got a turning point again, but this one, it's our minimum at the minimum value. So it's a minimum turning point where x here is 270 and y is -1. So we are going to have this as 270 degrees versus -1. So the question might ask you to state or to just indicate your turning points after as a question. So the turning point is where your graph is having what? Its maximum or a minimum value. That's at the turning point. So that is how you can simply take this, the value of x versus the value of y. Remember, it's a point, and a point is given in terms of x and followed by y. So this is the idea now that you're supposed to work with or to use. All right. So with the same information, you are going to see that also these are the same properties that you're going to have the graph of cosine to be drawn. So in order for us to draw this, we are going to have the same thing. Remember, I said these two graphs, they share something in common. How you separate your angles is the same. So we are going to see that on the graph of cosine of x, this cos x, all right, we are going to have our angles again separated the same way as the previous part. All right, so let us see what we are going to have at the end. So with the values of x in this case, all right, so we've got our x and y here from 0 up to 360, just like this: 0, 90 degrees, 180, 270, 360 degrees. All right, but this time the values of y, you're going to see that they are not going to be the same. They are not going to be the same. All right, so let us have our calculator so that we see that these values are not going to be the same. All right, so let's check now. We are dealing with cos. All right, so this is cos x. Our x at the first place is 0, so it's going to be cos of 0 like this, which is going to give us a positive one. Take note of what we are obtaining in this case. So here we are obtaining a positive one. We do the same thing when our x is 90. So this time here we shall have 90, which is a 0. So this gives us a 0. We do the same thing on 180. If we put 180 here, 180 degrees, that will be a -1. So you're going to see that this is going to affect us through on and so on and so on. On 270, you're going to obtain a 0, at 360, a 1. All right, so this is what we have. So meaning to say we can sketch our graphs. We have our graph in this case. All right, so just like the previous part, we shall need our Cartesian plan where we have the values of x and y. All right, so this is for x and this is for y. So taking our values again from 0 degrees up to 360, separated by 90 degrees each. So we've got 0, 90, 180, 270, 360 degrees. All right. From -1 up to +1, that's our minimum values at -1. The maximum value that we can have here is at +1. So these are the most important points to be noted. So as we saw here that we are going to mark the points in order for us to draw this graph, this is what we are going to do again. We've got x being 0, y being 1. So this is 0 versus 1. So this point is the 1 and the y-axis. We've got 90 versus 0. X is 90, y is 0. So this is the point, x being 90, y being 0. We move on, 180 versus -1, meaning to say x is 180, y is -1. Where these two meet, that is somewhere here, you mark your point. All right, at 270 here, which is 270 versus 0, you're going to mark a point. 360 versus 1, 360 versus 1, maybe somewhere there. So these were the points that we're supposed to mark, to join. In this case, the one that are giving us the graph of course. So actually the graph of course, it's like this. It is a turning point like this, a turning point, another turning point. So on this one, we must join, minding that these were actually turning points there. So meaning to say we shall have something like this here. Okay, something like this up to this point. Then you join up to this point using freehand. All right, also the same concept this side. You are going to join here to the turning point of our graph here. So this is how the shape of the graph, of course. So I'm worried about you guys knowing the shape of the graph. What is important is for you to understand the shape of the graph, how the graph of cosine looks like. So the most important part, noting our turning point, which is the visible turning point in this case here. This point is not complete because we are not having this side. Also, this point is not complete because we do not have this side. So meaning to say this is the visible turning point at x is 180 versus -1 for y. This is the point that corresponds there. So at this point, x is 180 degrees, y is -1. It's a turning point that we are seeing there. Y list, where the graph meets with the x-axis here, these are the solutions of the graph, meaning to say if cos of x, if we are given a condition where cos of x is equal to 0, these are the points that the graph meets with the x-axis. That is where cos x is equal to 0. That means it's at x is equal to 90 degrees and at x is equal to 270 degrees. This is where our graph of course will be equal to 0. So it is the same idea here, even for the graph of sine. If we had to consider this for the graph of sine, in this case, if sine x is equal to 0, what does it mean if sine x is equal to 0? What are the values of x there which makes this graph to be equal to 0? That's at this point, at this point, at this point, where the graph meets with the horizontal axis. So that is going to be at 0 degrees. So x is going to be 0 degrees, or at this point where it meets with the horizontal, that is at 180 degrees, or at this point, which is at what? 360 degrees. So these are the intercepts of the graph and the x-axis, or the values of x if sine x is equal to 0. So if the question is asking you to solve the equation after you've drawn the graph, sine x is equal to 0, you are simply taking the values of x that is at the intersection of the graph and what? And the x-axis. So that is the idea. The same with cos, where the graph of cos meets with the x-axis, that is where cos x will be equal to 0. So these are the two most important graphs that we have in our syllabus that you need to understand, and also their effects. We shall see these effects when we are sketching the graphs later on, but let me just explain one or two so that when we are relating, you'll be understanding the idea. So we have got effects on these graphs that can actually happen. So the effects on the graphs, on the graph of sine x and cosine of x. Given a condition, the first effect that we shall see is that, let's say we have got the graph of y is equal to a sine of x, or we are talking about the graph of y is equal to a cos of x, where now there is a number that is affecting cos here, that is affecting sine. This number that we see here, it simply represents the amplitude of the graph. That is where our graph can be taken from maximum to minimum. So this value here can actually give us where our graph is going to have its maximum or minimum values. All right, remember, the graph of sine, we saw that it is going to be like this from our previous presentation. This is just a sketch. So if we are talking about the maximum value here, it is going to correspond at A. The minimum value is going to correspond at minus A. The value here that is affecting is the one that you see on the maximum and also on the minimum. So it is the same thing even if we were to have the graph of cosine. Remember, the graph of cosine was like this. It was something like this. So meaning to say this value here is going to correspond to the value of A. This value is going to correspond to the value of minus A. So this value, that is how it affects. It affects our maximum and our minimum values. All right. That is, we are going to see this. So meaning to say it is just going to shift our graph from the normal graph. Maybe our normal graph was like this, y is equal to sine x. It was like this below this graph like this. This was the graph of y is equal to sine x, all right? So let's say this is the graph of y is equal to sine of x, this one inside this one. This is the original graph of y is equal to sine x. Then maybe we're talking about this other graph here being the graph of y is equal to 5 sine x. This is just an example. So meaning to say this graph here is going to pass through this point at 5 and through this point at minus 5. While is the graph of y is equal to sine x, because here we are affected by 1 here, it's 1 sine x. So it is going to pass through 1. That is why we saw that our graph was having maximum value at 1 and minimum value at -1. What was the effect on this graph of sine x? It is the value that is affecting our sine x here, which is what? Which is a 1. So that's what I'm saying. This value here, it determines what is going to be your maximum and your minimum value. Here it's a 1, so you're going to have 1 and minus 1. The same with cos, it was like 1 cos x. So that's why you see your graph is taken from 1 up to -1. It cannot exceed this value that we see here. It cannot. If you see your graph now going up to 2, while here there's a 1, it's a mistake unless something is being added to this graph. Like I said, there are other effects. We can add a 2 to the graph after everything, so it can be shifted up. Like what I'm saying is that, let's say we've got this condition here. I think this one, the effect of A is clear. We've got another effect that can happen to these graphs, like for an example, like I said, these ones we shall consider more of them in our question papers. All right, let me just explain this before we attempt our questions. We've got the effect of let's say we've got y is equal to the sine of x plus a certain letter like this. Take note, this is separate. This is sine of x separate, not the same way as y is equal to sine x plus c like this. This is different, whereby you are adding on the angle. This one we are adding on the whole trigonometric expression. So it can be plus or minus x. So this one, it simply means you are going to shift the graph upwards or downwards. So meaning to say, if your original graph is like this, this is the graph of sine x. When you are now given +3 or plus whatever, we are going to see this graph is going to be shifted up. This point is even going to shift. We are going to see this point starting maybe somewhere here, having something like this, our graph being shifted up, or our graph being shifted down, starting at a certain point like this, have under this line. Every position is going to change where it is located. Here, we are going to see that it's only on the maximum where it is affected, but where your graph was at from the beginning here, these ones in the horizontal, they are going to remain as they are. This is the effect of the amplitude. But this effect, it shifts your graph either going up or going down, depending with what you're given. A plus means it is going to go up. So this is on a condition when this is a plus. When it is a plus C, it is going up. When it is a minus C, it is going to go down. So that is another effect that you need to understand, which is different from this one. This one is also a shift. Take note, there is also a shift, but it affects the horizontal. When you are given something like y is equal to the sine of x, let's say we've got x plus or minus b like this, or is the graph of y is equal to the cosine of x into plus or minus b, x plus or minus b like this. When x is directly affected here, it's x. It's different from the last one where we said y is equal to sine x plus or minus. This is separate. This sine x is standing on its own. Then this one is being added or subtracted later on. So these two, they are different. So this one, it shifts the graph horizontally, not vertically like what we saw here, that the graph is going up or down. If something is added to the trig after, your graph is either going up or going down. But this one, it's not affecting that way. This one, it's affecting horizontally. This one, it's a shift in the horizontal in this case. So we are going to experience a shift in the horizontal, whereby what I'm saying, trying to say is that if we're having our graph like this, I'm just going to explain from one graph, but the idea there is the same for all of the graphs. Let's say we had originally our graph of y is equal to sine x like this. We are going to see that when an angle is being added or subtracted, our graph is going to shift like maybe instead of starting at this point, we are going to have our graph starting at this point, going maybe something like this, and also not ending at 360, but ending at another point. So we have shifted our graph from its original position a certain step, from this position to this position, from this position to this position, from this point to this point, from this point to this point. Our graph is shifting, maintaining the same shape, but just the points they have shifted. That is the effect of this one. It's horizontal. So how do we affect now this horizontal shift that we are talking about? All right, if it is a plus b like this, it means it's a shift of b units to the left. Take note, it opposes what you see here. It's a plus b, but it represents a shift of b units to the left. So we shall properly see this when we are drawing these graphs. All right, we've got a negative. If it is a negative on that one, it means we are going to have the shift of b units in this case, but this time we are going to the right. So it's a shift of b units to the right. So your graph is going to shift to the right. When it is a negative, you're going to experience a shift of the right. When it's a positive, you're going to experience your shift of your graph going to the left. So this is something that you just need to understand or take into consideration whilst we are dealing with these graphs. All right, so I want us to check the questions like I said before and see how are these questions given and how are we supposed to attempt them. We are given here. The first part of our question was to we are given the function is defined by f of x. All right, so this is a function that we are given of f of x, which is equal to 2 cos of x plus 30. So take note these effects. We've got the 2 here, which we say this one affects the maximum and minimum values, where your maximum and minimum values are at. Then there is a plus 30 here. This one, it affects the angle, meaning to say our graph is going to shift from its original position. We are going to experience a shift, but this is not important. Even if you don't understand what is happening, it does not affect you to sketch this graph. No, it does not affect us at all. If we are to check here, we are now given to sketch the graph of f of x, which is equal to 2 cos of x plus 30. And also take note of the interval. You are starting from 0, ending up to 270, not 360. But on this one, we are supposed to be showing all the coordinates of the turning points and the intercepts with the axis. We talked about this part of turning points, and we are told the interval to use intervals of 30 degrees. The intervals are the ones that you separate your angles: 0, 30, 60, 90. These are the intervals that they're talking about to say we are going to use 30-degree interval. All right. So whenever you are given a condition like this, whereby you are adding or subtracting a certain angle here, the angle that you are adding or subtracting is the best to use on your interval. If it was x plus 45, it's best to use 45, all right? So that's what I'm trying to say here. So we are told that we are going to use the 30-degree interval. So the first thing that you're going to need is a sketch. Just like, our table of values in order for us to sketch this graph. So like I said, guys, our table of values, simply we need the values of x and y. All right. So this is too much. Let me have it this way. So we are going to need the values of x corresponding to the values of y in this case. All right. So that's it. So that's our x, our y. So as we are told that the interval that you're supposed to use is 30 degrees, it means if the first point is 0 degrees, you are going to add 30, 0 plus 30, which is 30. You add 30 plus 30 and so on. So this one, you can just do it on your calculator like this. You are saying the first point is 0, second point is 30. So the following one, you add 30 because you are separating by 30 degrees, you get a 60. The following one, you add 30 up to when you reach 270. So this is what you're going to do. You're going to be adding 30, 30, 30, 30 until you reach the 270. All right. So this is going to be 60 here, 90 degrees, 120 degrees, 150 degrees, 180 degrees, 210 degrees, 240 degrees, and the last one being 270 degrees. So this is how we're supposed to have these values separated. All right. So with this one, like I said, if you do not know the effect of this x plus 30, does not even affect, because all you need is taken from a table. So the table does not even lie. You can just take from your table direct. All right. So this is what you're going to have on your calculator, making sure that you have this direct. All right. So make sure that this is properly given. So we want the graph of 2 cos x plus 30. So we have got 2 cos, in this case, x is representing these angles 0, 30, 60. These are the values that x is representing. So if our first value is 0 on x, we are going to add 30 like this. All right, we are going to add 30 like this, which is going to give us square root of 3. That's 1,73. Just one decimal place. This is 1,7. All right, so here we are going to obtain 1,7. You do the same thing if your x is 30 degrees. So go back to the calculator. Remember, this is where our x is, x plus 30. So this is the value that can change. Now it's 30. So we are going to obtain a 1 in this case. All right. We move on to the second one. If our x is 60, we are going to put 60 here. Remember, x is represented here. So this is now 62 cos 60 plus 30, which is a 0, and so on. You go to the 90, your x now is represented as 90. So you have to change here. Now we have got a 90 there. So this will give us -1, 120, and so on. So this is how you simply work out these values. You move on to 120 like this. That is going to be negative square root of 3, which is -1,7. So we've got -1,7 in this case. So like I said, you're going to do this up to the last term of 270. All right, so at 150, we are going to obtain -2, -1,7 at 180, 210 versus -1, 240 versus a 0, 270 versus a 1. So these are the values of y corresponding from the values of x. These are the ones that you're supposed to draw, to mark on your graph. Then you can be able to draw the graph that you are given in this case. All right, so I want us to take these values here on our graph here. This is where we are having our graph. I don't know if it is going to be clear. So I want to explain from this graph first before we put in our values. From this graph that we see, I have chosen here, I want to explain with this graph that we see here. I have chosen that the first five boxes, they represent that, like 1, 2, 3, 4, and so on. So this is, we are counting the 5 boxes, which means this line, all right, this line of mine is just a little bit shifted. It's supposed to be directly at 5. Let me try to shift this line here, meaning to say we are supposed to have it directly at this point. All right, so that here we are going to have what? 1, 2, 3, 4, 5. All right, so the 5 boxes are representing what? Are representing 30. So it's going to be 30 up to 270 degrees. Then on the y values, I'm just choosing to take the whole box like this, the 10 boxes here, because these are first 5, another 5. I just combine them like the whole of this to be my 2 centimeters representing 1, which means we're talking about 10 boxes there. So this is how I'm going to take my points on the graph. All right, so we just have to mark these corresponding points from the first up to the last one. So we're not going to waste much time. Let me show you. The first one, it's 0 versus 1,7. X, it's 0. Y, it's 1,7. So we need a value that corresponds to x when it is 0 here. And this one, it's 1,7. So if we are to take note, 1,7 is found after 1. So this is 1 here. 1, 1, 2, 3, 4, 5, 6, 7. Each box represents 0, 1. Since these are 10 boxes, so this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we've got a 1. So each box there is representing a comma 1 in this case. So 0 versus 1,7. This is 1, 1, 1, 2, 3, 4, 5, 6, 7. So that's where you mark your first point. So that's how you play around with this. You are supposed to have exact thing. All right, here we have got 30 versus 1, 30 degrees versus 1. So it's the same thing here on our graph. We need 30 degrees. This is 30 degrees versus 1. So where these two meet, 30 here and 1 on this side, they meet where? At this point. Where they meet, you are going to mark a point. So if you check on this one, it was a November 2020 question paper that we are working with. And there, if you check on the memo, if you are working with this same question paper, you see that they had wrong values there that they were used. They used for the graph of 2 cos of x minus 30 instead of 2 cos x plus 30, because you might wonder to say, why is it that what we are doing now is not corresponding to your values? That was actually wrong. If you use your calculator properly, you see that those values, they do not even correspond. All right, so anyways, let us finish up. We said here we are going to move on to 60 versus 0 in this case. All right, so this is 60 versus 0. So 60 here versus 0, that is at the point where there is 60 like this, 60 versus 0. So we are going to do this up to the last point. All right, let us just move on to this one, 90 versus minus 1. So we are going to need 90 and minus 1 here. All right, so that is 90 here versus minus 1. So like I said, guys, we are going to do this, okay? So at 120, we saw that 120 was versus minus 1,7. So meaning to say, at 120, we are going to need somewhere here. It was negative 1,7. So this is it, 120, negative 1, negative 1,5, negative 1,6, negative 1,7, somewhere here. that is for 120, all right? Then 150 was versus -2, so it's 150 versus -2 here. You mark your point. 180 also was versus -1,7, which is direct at this point, -1,7 somewhere here. 210, remember, was versus -1, so -1 somewhere here. 240 was versus 0 on our table, so that's 240 versus 0. Then 270 was versus +1. So we are taking on our table, guys, as it was, all right? So this 270 here was versus 1. Remember 1 here on top. So that's 270 versus 1 somewhere there. 270 direct, 2 to 1 straight. So with these points, you are done. What you need is to join these points. But these points are not just taken from anywhere. We took these points from where? From our table. This one, 270 versus 240 versus, that is how you are going to have this graph drawn. All right, so let us have this. So in this case, I don't know if I'm going to have this in a smooth way, but you're supposed to obtain a smooth graph joined here. So it was supposed to be something like this from this point, joined to this point, something like this. So that's supposed to be smooth graph, all right? This one is supposed to be smooth. All right, so to this point, you join to this point. It's a free hand. You're supposed to use free hand, all right? To this point, you join to this point, all right? This one, here it's supposed to be a turning point. You're supposed to show that there is what? A turning point there. I want us to have something like this here, okay? This one is a turning point at this point, all right? Then it goes up, then to this side like this, all right? This is supposed to be like a KV something, all right, something like this. All right, this one of mine is not that smooth, but as for you guys, you are supposed to have a smooth graph. And what is important is that these points, they are visible where your graph is passing through. They are visible, these points. If they are visible, they are not going to worry about a lot of things. All right, so that was the graph that we're being asked to draw, which is a function of f of x is equal to 2 cos x plus 30. So this is the graph of y is equal to 2 cos, let us just write it here, y is equal to the 2 cosine of x plus 30 degrees. All right, so this is the graph that we are being asked to draw or to sketch. What you need is to have your table of values, then you can mark your points on the graph, join them. All right, so let us check the other part of the question. We are now given to write the x-coordinate. Take note here what we need. Write down the x-coordinate of the points at which 2 cos x plus 30 is equal to 1. They are saying this whole graph is equal to 1. So where is it? This one here, it's like f of x. Take note, this is f of x is equal to. So they are simply saying, where are the values of x if f of x this time, because this is f of x, this one, 2 cos x plus 30, that represents f of x. So what are the values of x that corresponds when f of x is equal to 1? We do not even need a graph, because even here we can check, because y represents f of x. For the values of x, this is our f of x. So which values of x are we seeing on the table here, where our f of x, which is y, when it is equal to 1? So you can check here, y is equal to 1 at 30 degrees. Also here, y is equal to 1 at 270 degrees. So meaning to say the values of x that we need there are 30 degrees, which corresponds to 1. So x is equal to 30 degrees, or the other one here, 270 degrees versus what? 270 degrees versus 1. So here we need the x coordinate. It's not a point. Or you can take this one from the graph. If you check also from the graph, you need the values of x, whereby your graph is passing through 1. So what you need is to work with is here. This is the line of y is equal. Remember, y is equal to, these are the horizontal lines for y is equal to. So y is equal to 1 is going to be at this, okay, let me use this one so that we can just interchange this part. All right, so this part actually removed everything. Anyways, no problem. Let us check. But if you check, that was the idea that you're going to use. You could have taken this answer from your graph. And so this is how you play around with these questions. If we check here, we've got another scenario again. This time we are given two graphs, but still the idea there remains the same. So we are given, let us check our graphs. We are given the graph of the equations of f of x is equal to 2 cos x, and the other one is 4 sine x minus 2. So here we are going to subtract 2 on 4 sine x, and we are asked to draw the graphs of the graph of the given equations on the same set. Take note, on the same set of axes from 0 up to 180 degrees. Show all the intercepts on the x of the axis and the coordinates of the turning points. All right, so yes, here, like I said, the graph of cosine, if you are not given like x plus 30 degrees or x plus 45 degrees, you are going to simply use the 90-degree interval. But if we are to check here, guys, let us see what we have. We are only going to have 3 points, like from 0 to 180. We are going to have 0, 90 degrees, 180 degrees, which are just 2 points, which is fine. But these points, they are a few. We are talking about few points in this case, which was fine. But let us try to have at least more points from there, so we can even try to separate using the 30-degree interval, so that at least we have got enough points to plot or enough points to use. But even if you used 0, 90, 180 degrees, still it was fine. But these points, they are few, they are not that much. So just try to have at least more points from there. All right, so we are going to start with one of f of x is equal to the 2 cosine of x, or let us just combine them at once, because we are going to use the same values and so on. So I'm just going to combine them, but please bear with me whilst I am having this. So let us have x. Remember, we are going to need the values of y, which corresponds. So we are going to have the values of y for f of x. All right, then we are going to need the values of y for gx. All right, so that is what we are going to have. So these values of y here, they are not for they are for the two graphs. So we've got the first one, the values of y here for f of x. Then we have got the values of y that are going to represent or to be for gx, this one. All right, so like I said, to use 0, 90, 180, there are few points. Let us just have more points. All right, so we are just going to have more points there. So you can even separate by 30 degrees. We saw that one of 30 degrees last time. So it was 0, 30, 60 degrees, 90 degrees. We add 30, that is going to be 120. We add 30, 150. We add 30, 180. At least these points, they are widely separated. I mean, they are separated from each other. We've got a lot of points that we can consider, not just 3 points. Yes, you can do that, which is fine, but you can just try to make it more clearer than what it can look like. All right, so we are going to start with the 2 cos x, which is our f of x here. Remember, f of x is 2 cos x. So this is the one that you're going to start with. You fill in according from our calculator. So I'm just going to show you the first two values, then the rest you can continue with them. All right, so on our calculator, we've got 2 cos x. This is your f of x, 2 cos x. So it is going to be 2 cos our x at the first part, it's 0. So that is our 2 cos x, which is going to be at 2 in this case. All right, so this one is going to correspond at 2. Then we move on again. The second x is 30 degrees. So here we are going to change into 30 degrees. which is going to be 1,7 to 1 decimal place. So that's 1,7. 60 degrees, the same thing, 2 cos 60, and so on, which is going to be a 1. So I want you to fill in these values the same way that I'm using on the calculator. You're going to see 90 is going to give you a 0, 120, -1, 150, -1,7, and at 180, it is going to correspond at -2. So that is what you're going to do. You move on to the graph of gx, which is 4 sine x minus 1. So here we are going to have the same thing on our calculator, but this time we are working with sine x. How do you present it on a calculator? We need 4 sine x. So it is going to be 4 sine of x. X is the first value that you're working with, of which on our table, the first value is 0. You close that bracket. Don't minus the 2 inside. You close the bracket of the angle. Then you subtract the 2 now like this. So we are going to obtain -2. So the first value here is -2. When x is 30 degrees, we do the same thing. X inside the bracket, that's where you put 30 inside the bracket. That's 4 sine x. Close the bracket, minus a 2. So this one is going to give us a 0. We do the same thing when our x is 60 degrees. We put here a 60 degrees. All right, so that will be a 60 like this, which is as a decimal, that's 1,46. 1,46. So to 1 decimal place is going to be 1,5. So that is going to be a 1,5. At 90 degrees, we do the same thing. When our x is 90 degrees, we are going to obtain 2. So this is affecting the values of gx. This is the graph of gx that we are talking about. So we are going to have the same thing throughout. At 120, we are going to obtain 1,45, which is 1,5. At 150, you are going to obtain a 0. At 120, you are going to obtain a -2. So please take note that these values here of y, they are for f of x. These values, they are for f of x. So these are the values that you are going to start with. All right, so you're going to start with these values. We can even start with the ones for gx, it's fine, but let us just start with the ones for f of x. So on our graph here, just like the previous part, but this time I try to separate. It's no longer directly the same. If you check our angles here, they are now using 10 boxes here. From this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to represent 30 degrees, which is not an effect. Maybe your 30 degrees is at this point. It's fine. Still one. You say 30, 60, 90, 180 up. It's going to be fine, but it was just going to be too close. That's why I just choose to separate here. Then 10 boxes here, they represent 1. 10 boxes here, they represent 1. So you can choose maybe 5 boxes up to this point, because this is the type of the graph paper that you have in exam. So you can choose to say, this is 30 degrees, this is 1. According to your scale, you maintain that. It's up to you, this part, because you are not given a scale. So here I just chose to use something like this. All right, so like I said, we are going to start with the graph of gx. So on our graph of gx, the corresponding values are as follows: 0 degrees versus 2, 0 versus 2. So we're going to mark 0 versus 2 on our graph. That's 0 here versus 2. All right, so we are going to mark 0 versus 2. All right, like this. We move on to the second point. That's for still on f of x. We are still considering f of x. So it's 30 degrees versus 1,7. So we need 30 degrees versus 1,7. This is 30 degrees. Where is 1,7? Remember, I said each box, there are 10 boxes. So it's going to be 0, 1, 2, and so on. So 30, this is 1. This is 1,5, 1,6, 1,7, somewhere there. So you count according to your scale, because here there are 10 boxes. So this is 0, 1, 2, up to 1. So that is how you take this. You have to be careful about the boxes that you have taken here. If 10 boxes are representing 1, meaning to say 1,5, it's in between 1 and 2. So 1,7, we just count 2 boxes from that 1,5. All right. So that's the idea there. All right. So that is for 30. We move on to the other one. 60, it's versus 1. So we're going to move on to 60 versus 1 here. That's 60 versus 1. So 1 is here. So that is 60 versus 1 there. All right. So we're going to do this up to the last point. We saw that 90 was versus 0 for the graph of f of x. We are still looking onto f of x. And 120 was versus -1. 120 versus -1. 150 was versus -1,7. So -1,7, it means we are again but down here 150, -1 here, -1,5, -1,7 is somewhere here just before 2, after -1,5 and before -2. And 180 was at -2. This was our 180. So these were the points that we are going to have if you were to mark these points properly for this graph of f of x. So the next thing was to join, to sketch the graph now. So it was supposed to be something like this. You're supposed to join these points properly. It was something of this nature to this point. All right. To this point. All right, this one is not smooth here to this point, so you must have something that is smooth, guys. All right, then to this point. All right, then you join to this point. All right, there's supposed to be like a curve, something like that. So that's something like this. All right, just a curve like this. Then here is gonna be a curve. Let it not be a straight line. No, it's not a straight line. This one, it's not. This is how it looks like. All right, in reals, but yes, that it's wide open. All right, so this is the graph of f of x. As we saw, we're talking about f of x here, which is equal to take note, our graph of f of x here is equal to what? 2 cos x. So this is equal to 2 cos of x. All right, so as we can see, from the last time that I was explaining, from this graph, we are going to see the maximum value is going to be at 2. The minimum value is going to correspond at -2. As you can see, this is taken from what? This is simply taken from, sorry, I want us to see here. This is simply taken from where? From this value of 2. It affects our maximum and our minimum value at what? At -2, if you understand from those effects that we talked about. So we are going to draw the same, the other graph on the same axis, which is the graph of gx this time. All right, so the graph of gx, we are dealing with this side here. This is what we have on our gx. Let me use this one. So remember, this is our gx. So we are going to be concentrating with these values here. These are the values that we are going to use. 0 versus -2, and so on and so on. All right, so the first one is at x, which is 0 versus -2. So we're going to mark this point here, 0 versus -2. We move on to the second point, that is at 30 degrees versus 0. Take note, the angle at x versus the value of y there, which is what? Which is 0. So that's 30 versus 0. So we are going to mark our point 30 here versus 0. That is the point on the x-axis. All right, we do the same. Here we now have 60 versus 1,5. So 1,5 is in between 1 and what? 1 and 2. 60 between 1,5. This is 2, this is 1. So in between here, that's where we have 1,5. So it's 60 versus what? 60 versus 1,5. In between there, between 1 and what? And 2. All right. So that is what you're going to have. Let's check another one. Here is going to be 90 versus 2. In this case, we're going to have 90 versus 2. At 90 here is going to be versus 2. That's the point here, 90 versus 2. Okay, so that's it. You mark everything. 1,5 at 120. So it's 120 versus 1,5. 120 here versus 1,5. 1,5 again is this point here that is corresponding, but now it must be at 120 straight versus 1,5. So that's where you're going to mark your point. Okay, then the other one, that is 150 versus 0 in this case. So this is 150 versus 0. So our angle is 150. The value there of x, it's 150, y being 0. So that is where we are going to have our point. Then the last one at 180 is versus -2. These two, they are the same, all right? So we are going to have the 180 versus -2, which is at the end, the same point as the previous one. So meaning to say these graphs will intersect, all right? These two graphs, they are going to intersect. So what you need now is to join these points. So if you check if the points are separated properly, it is not going to be difficult for us to join these points here. We need to join from this. Remember, this is our starting point, 0 versus -2. So we're going to join here up to 30, going up a smooth curve. So you're supposed to draw this on a smooth way. All right, this one is not smooth here. Let me try to rejoin here up to this point here. Then to the turning point, this is the turning point of our graph. It goes back to this point from the turning point. All right, so let's just have something smoother here. All right, to this turning point. Then you join also these two here. All right, then you also join these two here. So this is how our graph was supposed to be, like intersecting at this point and also intersecting at this point. So these graphs, they do intersect at these 2 points. So this was the graph of gx, remember. So this is the graph of gx, whereby gx was given as, let's check here. Our gx was given as 4 sine x minus 1. So this is the graph of 4 sine x minus 2, sorry. So that's 4 sine x minus 2. All right, so we are done in this case. So as you can see, it's important for you to know how to draw these graphs. You just need table values, then use your graphs properly. All right, then now they are saying on 6.42, read from the sketch. Now they are saying from this graph that you've drawn, you're supposed to read, meaning you're supposed to take the exact value. So read from this sketch of values, the values of x for which f of x is equal to gx. What do they mean? If these two graphs, they are equal, it means they are intersecting. So we need to refer to at the point of intersection. It happens at the point of intersection. All right, so that is the only condition that these two graphs will be equal at the point of intersection. But we are given that not only to be equal, it must be taken for the values of x from, take note now, from 90 to 180 degrees. That is where we are supposed to take our answer, from 90 to 180. All right, so if we check our graph, it was starting from 0 to 180, but now our answer is supposed to be from 90 to 180. Okay, our answers in the actual sense, they were supposed to be 2, because remember our graph is intersecting here. It is also intersecting here because I said it's at the point of intersection. But they are saying our values should be taken for the values of x from 90 up to 180 degrees. So meaning to say this value is not needed, because if we check, it's below 90. This is where we have 90. This value is actually before 9. But if we are to consider, we're going to take this value, we're going to find what is the corresponding value at this point. But here they are saying our values should be taken from 90 to 180. So this is the one that we are going to take here, where they intersect on the other hand. Yes, so they intersect. What is the value of x at the point of intersection? What is the value of x there corresponding? Our value of x is 180. So meaning to say these two graphs, they are going to intersect at x is equal to what? 180 degrees for values which are greater, which are in the interval of 90 to 180 in within this interval, in within that range that you're given. That's where our answer is supposed to be taken. All right, so that was the idea here. You have your table. From the table, properly present your graphs on the graph. That is how we can have this one. All right, then we've got another part. Let me check here if it is gonna make sense. There we have given again our two functions, again the function of f of x and the function of gx. So this one is 2 sine of 2x, but as we can see, it is going to give us the same concept here. But now what I want us to check is that this time, take note, there's a number that is affecting x here, x, 2x. It's multiplying direct. It's like we are drawing the graph of y is equal to a sine ex like this. So this part here, it affects our graph in terms of its ending point. Like if we are talking about this graph here, it was supposed to be from 0 to 360. So the period is being affected, meaning to say we are going to have our graph not ending at 360. Maybe our graph is going to end at 180 like this, or our graph is going to even exceed that 360 degrees. So it's because of this, it affects the period of the graph. So how do you check that how it affects the period of graph? You simply divide it to the original period. Our graph for sine x and cos x, they were ending at 360. That was our period. So if we are given now as 2 sine x, sine 2x like this, or cos 2x, you simply divide this by this number 2. If we divide, we are going to see our graph is going to end up at 180, where it was the complete graph that you used to have at 360. It's no longer going to be completed at 360. Remember, our graph was completing at 360 degrees, the graph of sine x. If it is like this now, it is not going to complete at 360. The complete cycle like this is going to be at 180 instead of 360. This one, that is how it affects, is the period of the graph. It affects what? The period of the graph in this case. If it was supposed to be ending at a certain value, it is going to affect where it is ending. So it is the same thing also with our intervals. Remember, we're separating 0, 90, 180. From separation of 90, we're separating each angle by 90, by 90, by 90 on a normal graph. So this time on a normal graph, we shall separate, instead of 90, you divide by 2, which is going to be 45 degrees. So it is best for us to separate these graphs by what? By 45 degrees. It's from what? The effect of this. It's best for us to separate our graphs by 45 degrees. All right, so this is what we are going to have, the values of x, then the values of y. All right, so let us just have our table. Just like the previous part, we shall just try to combine these values at the same time. All right, let me try to have it this way. All right, like this. So we shall have these values of y corresponding. Remember, these are the values of y, yes, but for the graph of what? For the graph of f of x. Then we've got also the values of y, but for the graph of gx in this case. All right, so we've got f of x and also the graph of gx in this case, if we are together. So this is our gx, our f of x. So like I said, it's best for us to separate this graph by 45, 45, 45. So we are going to have 0, separate by 45, we are going to have 45, 45 plus 45, that is going to be 90, 90 plus 45, which is 135, 135 plus 45, which is 180. So we are going to end at 180 from 0 up to 180. Like I said, this graph, you're going to see that if we are to draw this, it is going to look the same way as the graph of a sine or the graph of a cosine, but ending at 180. That is the difference here. But the simplification does not change, guys. On our calculator, we are going to start with the graph of what? F of x. So this is 2 sine 2x. So on your calculator, everything is supposed to be clearly indicated. So we've got 2 sine, this is 2x. So we are going to have 2 sine 2 times, that is 2x. The value of x, which is this one, 0.45. So the first value of x is a 0 like this. We close the bracket now. So that is going to be a 0. So here we are going to have a 0. When our x is 45, we do the same thing, 2 times 45. So this one is 2 times 45, which is going to be a 2. The same thing for 90 in the bracket, 2 times 90 here in place of 45. We are going to have 92 times x, which is 0 in this case. For 135, we've got the same thing, 2 times 135 degrees, which is going to be -2. For 180, that's the same thing here, 2 by 180 degrees. So this one is going to give us a 0. So we're going to see that throughout, even if we are to change the second now for gx is affecting cos of x. This is our gx. So here we shall be working with cos of x. So we've got cos of 2x. So we just need cos of 2 times our x. So our x, the first value of x, it's a 0 there like this, which is going to give us a 1. We move on to 45 degrees, the same thing. So it's simply 2 times 45 degrees, which is going to give us a 0. So this is the part that you're going to do throughout. So you're going to see at 90, this will be -1. At 135, this will be a 0. At 180, this will be a 1. So these were the values that you were going to need on your table. With this, you're going to show here we need also to indicate, show all the values, the turning points, and so on. We talked about each of turning points before. So let us save our graphs here. All right, so here this is what we have, 0.45 and so on and so on. I think I explained this issue of scale. It's now clear to us. All right, so we are going to start with the one for gx, for f of x, I mean, this one for f of x. So these are the values of y that you're going to need corresponding to x. So that's 0 versus 0 on the first one. X, it's 0. Y, it's 0 there. All right, so that's 0 versus 0 here. All right, we check the other point. 45 versus 2. So that is going to be 45 versus 2. 45 versus 2. So this is where we have 2. That's 45 here versus 2. You mark your point. That's it. 90 was versus 0. You do the same. 90 versus 0. 135 was versus -2. 135 was versus -2. 180 was versus 0. So this is how we are supposed to mark your points. After marking these points, you are to join now. So by joining these now, we are going to see that, all right, we're going to have something like this. From 0 here to this point. After this point, we go down, all right, like this to this point. All right, this one is not that enough. Let me just redo here. Say it up to this point. This one is a turning point. So you're supposed to at least show a turning point concept. Then from the turning point, it goes to this point along the 0 axis. Then from there, we are going to reach this point at a turning point. All right, then it goes up to this point like this. So this is what our function was supposed to. As you can see, it's a normal graph of the sine x that we are used to, but now it's completing its cycle along at 180 degrees, whereby these are the turning points of our graph. If we are to check here where this graph is 10 at this maximum value, the value of x there is 45 versus the value of y, which is 2. So that means we've got 45 degrees versus 2 as our turning point. Then another turning point, which is our minimum turning point. Remember, this graph has got 2 points, maximum and minimum. The minimum turning point at this point of 130, this one, versus what? Versus -2. So x there, like I said, it's an angle, but the value of y is just a normal value, which is -2. It's a turning point again. So this, we are talking about a turning point. Here, we are talking about a turning point again. maximum and minimum. All right, so that was the graph of g of f of x and f of x. I'm just going to write f of x, but you're supposed to write the equation, but here I'm just going to write f of x. So let us move on and check our gx. All right, now we are going to be using this part now, these values of y for our gx. So that's 0 versus 1. All right, so we're going to use the same concept just like the previous one. So we're going to mark our points. We said 0 versus 1. Okay, that's 0 versus 1, which is somewhere here. Okay, let's check properly. All right, that's it, 0 versus 1. Then 45 here, it's versus 0. So 45 versus 0 here, 45 versus 0 like here. We do the same thing. 90 was versus minus 1. 90 versus minus 1. 135 was versus 0. All right, 180 was versus 1 on this graph of what? The cos of 2x, the one that we are doing. This is how points were being connected. So with these points that we are having, we are simply going to join them now to have our graph drawn. All right, so we are just going to join our points as to this point. From this point to the turning point. So this one, it's a turning point. This one, it goes up to this point of 135 to the last point here, something like this. So this is how our graph was supposed to look like. So this is the graph of gx in this case, all right? But taking note that the turning point is here. This is where our graph is having a turning point, 90 versus what? Now it's at 90 degrees versus 90, -1. It's a turning point of this graph, this point where x is 90, y is at what? At -1. So that's how you play around with these graphs to sketch them on your graphs. All right, now the question here is, after we've drawn this, the question is, use the graph to read off the values of x if 2 tan to x is equal to 1. Here they're just playing around with us here. Tan, we can see we never talked of tan before. Even on these graphs that we see, we do not have any tan. They want to play around with us. Remember, in our trigonometry, we understand that the tan of x is equivalent to the sine of x over the cosine of x. And on top here, we can see that there is a sine of x there, there is a cos of x there. So they just wanted to play around those values that we had before. So taking this into consideration, this is 2 tan x, meaning to say this is same as 2 sine 2x like this over the cosine of 2x. In order for us to obtain tan, these two should be the same. Sine x, cos x. So it's sine 2x over cos 2x. It gives us tan 2x. So this was the expression here, tan 2x, this one. It means sine 2x over cos 2x, but there's a 2 that is affecting, so it's 2 sine, which is equal to what? Which is equal to 1 in this case. So they are saying this tan 2x, this one, which is sine 2x over cos x, is equal to 1. If you were to cross multiply here, we are going to see something that is simply hidden from this part. 1 times 2 sine x, you are going to have 2 sine 2x, which is equal to cos 2x times 1, which is going to give us cos 2x. If we check, this is what we have originally here, sine 2x, 2 sine 2x, which is your f of x. So here they are simply saying f of x is equal to cos x. Cos 2x, what is cos 2x? Cos 2x is gx. They are simply saying, what are the values of x where f of x is equal to gx? And I said this condition happens at a point of intersection. We simply think of what? The point of intersection. That is the point that you're supposed to be thinking of, the point of intersection. And also from 0 to 180, meaning to say this time we are taking all the values, not like that one that was limiting us. This time we are taking from where we started, 0 to 180, This is the same interval from 0 to 180. So we simply need these values where your graph, where the graph is actually, where these two graphs intersect, all right? We are told to use the graph. So we need our graph in this case, all right? Where f of x is equal to gx. So let us check the point of intersection. So this is where the graphs are intersecting here. So your graphs, they are intersecting at this point. You check the value of x that is corresponding there. Also, they are intersecting at this point. You check the value of x that is corresponding there. All right. So if we are to take note here, we are given, we are supposed to read properly according to our scale. We are supposed to read properly these values, all right, where they are meeting. In this case, we need to read properly. So it depends with how we are taking your values to say. Let's say here we are talking about these 10 boxes. Like I said, these 10 boxes, they represent 45 degrees. So you have to ask yourself now, how many boxes are you having according to this part here that you're having? So you're supposed to obtain or to have the exact part. You take whatever that you are seeing on your graph here. Maybe there are 1, 2, 3. Yes, not that, because it's not that exact. Maybe there are 3. I'm just giving an example. Say these, there are 3. You ask yourself, what is the equivalent of the angle? So it's going to be 3/10 times 45 degrees. So that's how you obtain the angle. Then you have to you take it to proportion. You have to ask yourself in proportion. That is how you ask. That is how you attempt this question. So if you are representing 10 boxes like this one, 45, you can also ask yourself to say, if these 10 boxes represents 45, what about each box? What does it represent? Each of these smaller boxes, if 10 boxes are representing 45, you ask yourself each box. So you're going to say 10 boxes represents 45 degrees. What about each box? One box. So there we're talking about the boxes here that are on our graph. So what about one box? It's going to be what? 1/10 times 45, which is going to be 4,5. So it means each and every part that we see here is going to be 4,5, 4,5, 4,5, 4,5, 4,5. So you can read from there. If there are 3, you're going to be say 4,5 times 3. If there are 7, so that's how you are going to take. All right. So in this case, our exact values were supposed to be approximately at 13 degrees, and the other x here at 103 degrees. So I just want you to properly read. So this one, you are supposed to read what you see from your graph, although it's not that smooth, because these graphs, when you are drawing them or when you are sketching them, you are using freehand. So this value, you won't have that exact value as you expect it to be, but this is what we're supposed to have. So it's simply, we're supposed to take this graph from where f of x, that was the most important part, that was hidden from this one, that we are supposed to take from f of x is equal to gx. But look the way that they ask this question. So this is how we work with these graphs. All we need is to work with more question papers, more revisions as we are preparing for the exams which are ahead of time. Make sure that you understand each and every graph that you are given, how to draw, how to sketch the graph that you be given. That is the most important part. But for now, that's it, guys, from Mason African Motives. Till we meet again.